to the lecture of sorting elements using C++. Sorting is actually arranging the elements in ascending or descending order. So it depends on the requirements of the user to sort the elements in a way such that the first element may be the smallest and the last element may be the largest one, and the interior members or elements may have a similar order in increasing or in decreasing. So if you want to sort the elements, for that sorting we have a number of approaches and techniques that can be used to sort the elements. Here in this lecture we are going to discuss the bubble sorting. Bubble sorting is one of the techniques where we can use the sorting approach of bubble sort concept, where we take the largest element and move that largest element to the end of the elements if we are interested in ascending order. And if someone want to have descending order of the sorting, so then we will select the smallest element of the array and will move that element to the end of the elements. So let's see how can we visualize this concept using a series of number. Here you can see we have 5, 2, 1 and 3, a series of number. This series can also be represented as an array of integer in C++. Okay, so irrespective of the data type, sorting can be used on any data type. Okay, here we can see we have integer data types, so that technique can be used on this integer data types. Okay, so as I have discussed that if we are interested in ascending order, so then we should take the largest element to the end of the elements, to the end of the array. So we may have multiple passes, okay, and let's see how can we execute multiple passes through this array, through this series of numbers. Here you can see in this series that these numbers are not even in ascending or descending order. These are not are not sorted. So we want to sort it in ascending order. The first element may be the smallest, and then gradually the number may be increasing order. So let's see how can we do this. Consider it using pass 1. So in pass 1 we will select the first element, and this element will be compared with the next neighbor element. Okay, and in this comparison we will see that if 5 is greater than 2, so if this is greater than 2, move this 5 to the position of the 2 and move this 2 back to the position of 5. So here you can see just like this, 5 has been moved to position of the 2, while 2 has been moved to the position of 5, while 1 and 3 are in the same position now. Okay, now this 5 will be compared with the next neighbor, and we will see if this 5 is greater than the next neighbor, which is 1, so we will move this 5 to the next position, and 1 will come back to the position of the 5, just like 2, 1, and 3 will on its own position. Okay, and 5 will move to the position of 1. Now in the fourth iteration we will see that if 5 is greater than 3, so of course 5 is greater than 3, therefore 5 will come to the end of the array and 3 will be moved back to the, or switched, or these values, these will be swapped with each other. So 5 and 3 are swapped with each other, and they replace their positions with each other. Okay, and this is 1 and this is 2. So this was the pass 1. In pass 1 we find out the largest element of this array, which is 5. So if 5 were in position in other than the position, now it is first. If that was in the other position, even in that case 5 will definitely come to the last position, because 5 is the largest element. Okay, now let's see and check this. We will execute pass 2 on this array, pass 2. So in pass 2, select the largest, select the first element, from the array and compare it with the next neighbor's element. So check it, if 2 is greater than 1, of course 2 is greater than 1. So 2 and 1 will be swapped with each other, and 2 will come to the position of 1 and 1 will come to the position of 2, and 3 and 5 will be on the same position. Now in the next iteration of pass 2, we will compare 2 with 3. So if these two numbers are compared with each other, so 2 is greater than 3? No, 2 is not greater than 3. So therefore 2 will remain on the same position and no swapping will be performed. Okay, 1, 2, 3 and 5. 1, 2, 3, 4, 5, because in pass 2 in second iteration we did not perform any swapping between the numbers. Then we will see and take the 3 and compare it with the 5. So when we compare 3 with 5, so if 3 is greater than 5, no, 3 is never greater than 5, so therefore swapping will not be performed. And we will see again 1, 2, 3 and 5. Okay, so there are many approaches to stop these passes and iterations. Okay, now you can see that the array is already been sorted. Even in the second last iteration the array was sorted. Okay, so therefore we need to stop these iterations somewhere, because it will, this process will continue unlimited time. So therefore one of the approach to stop these iteration is to declare a boolean flag, a bool type variable, I mean. Okay, so if there is no swapping be performed, so it means that the array is already sorted. This is one of the concept. So set flag, so if there is no swapping be performed in the array, so set flag is equal to 2. Okay, so if flag is equal to 2, it means that our array is sorted and there is no need of any other iteration. So therefore stop the iteration using break statement in the C++, okay, or even exit statement in the C++. Okay, so you have seen how can we use the bubble sorting technique to sort the array. Bubble means the largest bubble, the largest the element in the array will be picked up, okay, and will be taken to the last position, and then the second largest to the second last position, and so on and so forth. Okay, and this was the for ascending order. And if you are interested in the descending order, so you must take care of the comparison only. Okay, we have compared if the first element is greater than, but in descending order you shall compare that the first element should be less than the the second element. Okay, and in that case you will sort the array in descending order. So this is the whole concept of the bubble sorting technique. Let's see how can we implement this concept of bubble sorting using C++ programming. Okay, here you can see that we have defined a user-defined function with the void return type, and bubble sort is the name of function, while it takes two parameter. Okay, the argument. The first is array type, and the second one is integer n variable. So this array type can also be This array type can also be written as a pointer. For example, integer steric a. Okay. So this declaration in this one, both are the similar, because this array is also a pointer. We have already studied in our previous lectures that array are always act like a pointer. Okay. So using this declaration syntax or this declaration syntax, so both are legal and both can be, one of these can be used here. Okay, so we will receive an array, a pointer to the array here, and we will receive the size of the array as argument in the function. And this is the body of the user-defined function. And then we have three variables, integer I and j. Integer I is defined for, declared for the outer loop, while integer j is declared for the inner loop. So previously you saw that in bubble sort, we have passes, and in each pass we have iterations. Okay, so pass can be considered as outer loop, while the iteration inside the pass are considered to be the inner loop. So assumes that the outer loop is for passes, pass 1, pass 2 and pass 3, and inner loop is considered for the iterations inside the passes. Okay, we have also declared a temp variable which is used in the swapping of the two numbers. So you remember that we have swapped the numbers using bubble sorting. Okay, this is the outer loop starting from I is equal to 0, I is less than n. N is actually size of the array. Okay, so we will iterate this loop from 0 up to n numbers. Okay. Then we have the inner loop starting from 0, and j is less than n minus 1. N minus 1 means that we will not approaching to the last element. Okay, n minus 1, because we will not compare the last element to the next element. We don't have any next element in the array after the last element. Okay, so let me give an example, like if we have this 5, 1, 3 and 2, so the comparison will be performed with these two elements, or with these two elements, or with these two elements. So pick this element and compare it with the 2. We never take the last element and compare with any other next element. So therefore we don't need to move to this position and take this last element and compare to the another element. So there is no another or next element in the array. So what we need is to iterate only through these elements, and these will be compared to the next element. So consider this 3 as the last, and this will be taken for the comparison with the last element in the array. Okay. Okay, so then you can see that the inner loop has the logic of swapping two numbers. How this swapping is being performed, let's see here. This is the same coding of the swapping in our program. Okay, I just copied it here for for the illustration purposes. Okay, here you can see we have case 1 and case 2. If we have two numbers 5 and 1 in case A, okay, this is case A, and 5 is greater than 1, and we want to swap these two numbers using some logic, and this array has name small a. So if you execute this code on this array, so if A of j, so j is, for let's say, is the first position of this array, so it means j is equal to j is equal to 0. Okay, so what will be j plus 1? J plus 1 will be equal to this position. Sorry, j plus 1 is equal to 1. Okay, So j is equal to 0. If you add 1 to 0, so it means you are approaching to the location or index number 1. Okay. So a of j is equal to now 5, while j plus 1 is equal to 1. So a of 1 is equal to 1. This one, okay, the value. And see the logic, we are comparing that if 5 is greater than 1, so 5 is greater than 1, okay, then execute the block. So block will be executed and will assign a of j. A of j is equal to 5 to the temporary variable. So now temp will equal to 5. And then we assigning a of j plus 1. So a of j plus 1 is equal to the second position, the index 1, okay. So index 1, a of index 1 is equal to value 1, okay. So this one is being assigned to the a of j, a of 0. So it means that we are assigning one here, and this one is remain on the same place, okay. So there is no 5 while executing this statement, while during execution of this statement, okay, no 5 in the array, and that 5 has been assigned to the temporary variable, okay. Now execution of the last statement will assign the value of temporary variable into a of j plus 1. So it means that a of j plus 1 will be replaced with 5. Here you can see we have swapped two variables using this condition statement. So if first element is greater than the second element, then perform the swapping operation, okay. Okay, we have also another case where 1 and 5, okay, so 1 is not greater than 5, and apply this logic on this case too. So here a of j is equal to 1, while a of j plus 1 is equal to 5. 1 and 5. So if a of j, that is 1, is greater than a of j plus 1, that is 5, so the condition becomes false and this body will not be executed, okay. So this is how swapping will be performed in the bubble sorting, okay, the swapping of the two values into elements. And this is why we have declared the temp variable inside our program. So let's see back to our program here, okay. Now, we need to call this function from the main function. So from the main function, we have declared integer I, and there is an array of type integer which is named as b. And this b has assigned with some values 5, 2, 1, and 3. Okay. So it means that this array has size 1, 2, 3, 4. Okay. The size of array B is 4. If we want to call this user-defined function from the main function, so we will write the name of the bubble sort, the user-defined function, and then we'll pass the arguments from here. So we just need to pass the name of the array. So it means that we are passing the reference, the address of the array, the address of the first element of the array to the user-defined function. So therefore, we can also use the pointer declaration syntax here instead of declaring an array as well. Okay, so you have an option to use pointer or array syntax. Okay, so this will pass the array from here to the user-defined function. Actually, this will not pass the array. Okay, this will pass the address of the first element only. So it means that the user-defined function will operate, will process and will sort the original array, which is reside inside the main function. Okay. We are also passing the size of the array, which is 4, which will be cached here in, in integer n. Okay. So after sorting and executing of this user-defined function, this function will be uh, halted, and the execution will come back to the main function. And in main function, these remaining statement will be executed, which is a for loop on the array b. So if you execute these two statements, you will see the sorted array on the screen. So this is what all about how can we sort elements inside the array. So these elements are be of any type. We have used the integer type, and we can also use any other data type to sort the elements of the array using bubble sort technique. So there are many other techniques like insertion sort, okay, and selection sort, and many other that can be used using sorting the array, and then implement the C++ code for that. Okay, so if you have any question regarding the sorting, and especially the bubble sorting and the implementation of the bubble sorting in C++, so you may ask the question just below in the comment section, and I will try my best, inshallah, to answer all those questions. Thank you very much for watching this video and lecture.